Hi and welcome to Measurement Video 3. In this video we're going to talk about volume of simple shapes. So we'll be looking at some cubes, cuboids, and again a variety of prisms, although realistically a cylinder is the only other really interesting one. But we'll look at prisms generally. And then we're going to discuss the units related to volume and do a couple of examples. So volume is the total amount of space that a shape fills, or the total amount of space that fills a shape, which is kind of a capacity point of view. So if the thing that you're calculating volume was actually a vessel, how much water could you fit in there in centimeters cubed or meters cubed, etc. And that's what a volume represents. Volume is a three-dimensional value, so you should be multiplying three dimensions together. Let's look at some common volumes. So first of all, a cube. And again, a cube has three equal sides. We call them S, S, S. And the volume V of a cube is S times S times S. We multiply the three dimensions together, which is S cubed. So there's our first volume. Second, a rectangular prism. So in a rectangular prism, we have, and again, arbitrarily give them names, B for base. I shouldn't be putting those strokes there. H for height. And D for depth. And again, that's arbitrary. Now, to calculate the volume of a prism, we calculate the area of the front face and multiply by the depth. So in this case, the volume will be equal to B times H times by D. But this is a prism when we look at it in three different ways. So luckily for us, it doesn't matter what order we multiply B, H, and D by. We get B, H, D. If you're trying to find the volume of a rectangular prism, just multiply all the dimensions together and you'll be fine. Now we have a circular prism, which is called a cylinder. So in this cylinder we have the radius and we have the height, and they're our important features. And so the volume is equal to the area of the circle times by the height. And of course, if this cylinder was on its side, then it would be the area of the circle times by its depth. It's all just a naming thing. But we need to know the area of this consistent shape in the prism and multiply it by the height. And of course, in this case, the area of a cylinder is pi r squared h, because the area of that circle in the front is pi r squared. So that should be fairly trivial. And now, of course, moving forward to the general rule, and that is if you have a prism, any shape, so it really doesn't matter what this shape here is, then the volume of the prism is equal to the area of the front face multiplied by the length of the shape in this case, as I've used their length there, or the depth of the shape, or the height of the shape, or whatever you've called the site. And that will give you your volume. Remember, a prism is a shape that it doesn't matter where you cut it, it will always look the same. The face will always look the same. So if I cut this prism here, then this shape would appear on the inside there, and you can see it. There it is there. So it doesn't matter where I cut it, it's the same. That's a prism, and the volume of a prism is the area times by the length, depth, or height. And units. Volume is always measured in three dimensions. So the volume units are centimeters cubed, or millimeters cubed, or meters cubed, etc., etc. All of our units are cubic units, and they're all based on length. But also we could have miles cubed or feet cubed or anything like that, inches cubed. So now let's go down and have a look at some examples. Here's a really simple one. Looks a little bit like a pair of binoculars or something. But this shape, we're given that the front face here has an area of 25 millimeters cubed. So the volume will be equal to the area of the front face multiplied by the length, which in this case is the height. And we're told the area of the front face is 25, the length is 18, and so the volume, of course, is 450 millimeters cubed. And that's fairly trivial. And then example 2. Again, we have now a triangular prism, and so we need to calculate the area of the front face times by, in this case, I'm just going to say D, the depth. Now, the area of the front face here, area equals half base times height, which in this case is a half times 8 times 7, which is equal to 28 centimeters squared. And so the volume is equal to 28 times by the depth, which is 10, and that of course is 280 centimeters cubed. So there we calculated that front area multiplied by the depth to give us our volume of this shape. And last of all, example 3, which if you've watched my surface area video, I used exactly the same example. And if not, I'll go through the whole thing again now anyway. The volume of this shape is equal to the area of the front face times by the depth. Now, we're lucky here. The depth is given to us very clearly. It's 35. And the area of the front face is equal to one area plus a second area. And so we get this algorithm. So let me go through and find those two areas separately. We'll start with our blue one, which I'm going to call area 1. And then we'll go on and do this purple one, which I'll call area 2. So the blue one, area 1, is equal to 20 times 12, which is equal to 240. And area 2 is equal to half times pi r squared, because it's a semicircle. And in this case, we don't have a clear radius. But what we do have is that those two yellow sides match. They're opposite sides of a rectangle. And so therefore this top side is 12 centimeters, and that's the diameter. And so if the top side is 12 centimeters, that means the radius is 6. So the area is a half times pi times 6 squared, which is 18 pi. And so now we can calculate the volume quite easily. The volume is equal to the two areas, area 1 plus area 2 times by 35, which is 240 plus 18 pi times by 35. And that, of course, is equal to 296.55 times 35, which is equal to 10,379.2034 centimeters cubed. So we've calculated our areas in centimeters squared. We've added those together and multiplied by the depth to get our volume in centimeters cubed. So there we have it. There's some volume examples for cuboids, cubes, and cylinders, and just generally all prisms, with 3 examples and a little bit of a discussion about units. All the best.